So let's use the last tab on this same applet acceleration lab, very similar to the motion tab that we were using before, and just do a couple of experiments. One without friction, that'll be the first one we do, and one with friction. So the first one, I'm going to set friction to be 0. You can do that with this tab right here. So I'm going to set that to be 0. I'm going to put 50 grams for the man to push. I'm going to set the applied force, horizontal force that he applies to the box to be 100 newtons. And here is 50 grams. And so what would the acceleration be? So stop the video and think to yourself, what's the acceleration going to be? What's Newton's second law going to tell you here? Okay. All right. So what I'm going to do now is I'm going to the acceleration is going to pop up here. Clearly, it's going to be positive because it's going to be to the right, which is our positive direction. And it should be 100 newtons. That's the sum of the forces divided by 50 kilograms. Newton number 2 tells us that it should be 2 meters per second per second. So as you recall, this is 5, and this is 10, this is 15, this is 20. And so let's count how many seconds roughly it takes to get to 5 meters per second. And with a 2 meter per second acceleration, that should be 2.5 seconds. And so I'm going to start this, and I'm going to see how many seconds it takes, just counting 1001, 1002 to get to this first 5 meter per second mark. So here we go. 1001, 1002, 1003. 2.5. It's halfway between here and here. You can replay the tape if you like. Okay, so let's reset this and let's give ourselves some friction. So I'm going to just let it sit in the center here, and we'll take the same check marks that we did before, and we'll set the applied force to 100. Actually, I think what I have to do is I have to put 50 kilograms here first, but before it will let me do that. 100. Okay, and so now there's friction. And so as you recall, so we can just kind of play with this a little bit. As you recall, the amount of friction we get is going to be 125 newtons. As you can see from the red arrow, that's the maximum static friction possible with this particular system. So up to that point, I have the sum of forces equal to 0. But if I start getting bigger, my applied force now exceeds 125 newtons, so I get a force to the right. Okay, so let me do this if I can. Actually, it's more accurate for me to do it this way. Okay, so if I did that, I would have a net force of 50 newtons to the right. And so how many seconds would it take the box to get to 5 meters per second? So stop the video and see if you can figure that out. So how many seconds would it take if I start this for the box to get up to a 5 meter per second velocity? Okay, so you turn the video back on again, and what you should realize is Newton number 2 tells you that the acceleration for this box should be the net force 50 newtons divided by the mass 50 kilograms, and so it's 1 meter per second, which means it's going to take 5 seconds to get to 5 meters per second. Okay, so let's just confirm that with a little experiment here. 1001, 1002, 1003, 1004, 1005. Yep, pretty close. Okay. Now just one more thing. This is about friction now. And so we saw that with, I'm going to go ahead and reset this. We saw that when we had 50 grams, 50 kilograms, that we needed 125 let me reset this here. When we had 50 kilograms, that we needed an applied force of, let's check all these boxes here so we can see the sum of the forces. So the friction would go up to a maximum of 125. But beyond that, that was the maximum. Okay. All right. Now, okay, so I'm going to write that down. So for the particular friction between the box and the floor, if M is equal to 50 kilograms, the frictional force max is equal to 125 newtons. Okay, so now let's see what happens if I set M equal to 100 kilograms. Okay, so I can easily do that by putting another box on top of here, like that. Okay, so now I've got a total of 100 kilograms. So what would the maximum frictional force be in that case? And so I can continue to increase the applied force, and the frictional force can go all the way up to a maximum of 250. Okay, so in that case, F sub F max is equal to 250 newtons. All right, now we'll talk more about this later, but for static friction, friction means the force that resists motion when no motion is initially there, as is the case for this box. It's not moving initially. So static friction is proportional to the normal force. Okay, that would be the normal force acting between the this 100 or 50 kilograms, whatever the case may be. So here's the general situation. So say you have a mass M. There's some downward mg due to the weight, and there's some upward normal force. And what we're saying is that if you're trying to move the object this way with an F applied, I'll just do it this way this time, then there is a frictional force which resists the applied force, and it is proportional to this normal force. So more on that later.